Today we're going to look at how to solve this limit question. Here we have x goes to infinity and we have a square root minus another square root here. So if I simply just plug in x goes to infinity, let's see what we would get. We would get a square root of infinity plus 1 minus square root of infinity. Well, if you let me take a guess, what's that going to equal to? I would say it probably goes to 0 because in here you have a very, very large number, infinity essentially, and plus 1, which is also a very large number, minus the square root of infinity, which is also a very large number. Now, wouldn't that be just equal to 0? But I'm not sure at this point, because in this question, we're technically getting a case which you have infinity minus infinity case. And in calculus, this is called an indeterminate form. Which essentially means your limit is not determined at this moment. So we need to try some other method to solve for the answer. Okay, then let's see what we can do next. Here we have a square root. You can think of it as a square root a minus square root b. When we see this kind of format, we want to think about times it by its conjugate. Why? Because if we times it by its conjugate, in a way, we can eliminate the square root sign. And hopefully that can help us to solve this question a bit more easier. So let's try to time our function by its conjugate and see what we get. We have square root of x plus 1 minus square root of x. Then we times the square root of x plus 1 plus the square root of x. But here what we want to notice is if we just time by its conjugate, then we're changing the value for our function. So what we want to do is we want to times this part not only on the numerator but also on the denominator. So on the denominator we have the same function. So why do we do that? Because if we do that, essentially this part that we times with our original equation, this part is equal to 1, which means we did not change the value of our original function. Okay, and let's see what we get if we simplify this. On the top, we get x plus 1 minus x. And on the bottom, we get this part, which is the square root of x plus 1 plus square root of x. So x and negative x canceled, and we would get the limit as x goes to infinity 1 over square root of x plus 1 plus square root of x. So now we can see it very clear that the bottom we have something that is very, very large because the square root of infinity is also very large. So basically the bottom, our denominator goes to infinity. Therefore, 1 over infinity, the limit of that, we would get 0. And this is how you handle the question when you get an infinity minus infinity form.